Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been watching the videos that I've been making, you can consider liking these videos and subscribing to the channel. In this particular video, we are going to look into some of the advanced scheduling techniques that we use in Kubernetes. So when I say scheduling techniques, I actually mean the techniques or mechanisms that can be used to schedule your workload on some specific nodes, right? Because if we don't specify anything, Kubernetes scheduler is actually going to figure out which particular node a pod or a workload should be scheduled on, right? And these mechanisms that we have been talking about, for example, taints and tolerations in one of the previous videos, and in today's videos we are going to look into node selectors and node affinity. So these are some of the mechanisms using which we can actually instruct kube scheduler to consider some other factors while scheduling a pod or a workload on one of the Kubernetes nodes. So if we talk about node selector, so as the term suggests, using node selectors we can actually specify which particular node a pod should be scheduled on, right? So for example, let's say we have three node cluster, right? So this is one node, this is another, and this is third node, right? And let's say I have a workload, right? And this particular workload is supposed to be scheduled on node 1, let's say, right? So what we are going to do is we are just going to label this particular node 1 with some key, right? So for example, let's say key equals to v1, let's say, right? And then we can just specify in this particular pod that this particular pod should be scheduled on a node that has this particular label key and value, right? So this is it's that simple, right? You just have to label your node with a key and value pair, and in the pod you can specify that this particular workload should be scheduled on this particular node, right? Now here is the thing, we are going to actually look into the demo in a bit, but if we try to relate it with the taints and tolerations that we have covered or discussed about in one of the previous videos, even though this particular node has this key and value pair and this pod is actually configured to use node selector key equals to value, there is nothing that is going to stop any other pod to be scheduled on this particular node, right? So for example, let's say there is this another pod, right? And this pod is also needs to be scheduled somewhere. There are chances that this pod will be scheduled on this particular node, right? So there is nothing that's stopping another workloads to be scheduled on this particular node. So if we want to allow just specific set of pods to be scheduled on a specific node, we can use combination of taints and tolerations and node selector, right? So I think we have discussed about this in previous videos as well. So for example, let's say if we set some taint, right, on this particular node, right? So let's say if I just go ahead and try to set some taint, let's say I have set a taint on this particular node, right? Now if this particular pod is not actually tolerating that taint, this particular pod will not be scheduled on this particular node, right? But if we want to get this particular pod, that is let's say p1, to be scheduled on this particular node, we can actually specify the toleration, right, that we have applied, as well as node selector, right? So combination of these two things can be actually used to make sure that specific set of pods, only specific set of pods would be scheduled on a specific node, right? We cannot actually use one of them to make sure of that scenario, right? So let's just go ahead and try to look into how we can actually use node selector to schedule a workload on a specific pod, right? So I already have this Kubernetes cluster set up, and if I just go ahead and try to have a look into this pod manifest that I have created, right? So if we want to schedule this particular pod on, let's say, this node, right? So what we are going to do is we are going to label that node kubectl label node, and then the node name, and then key and value pair, right? So for example, let's say key is disk type and value is SSD, right? And then if we list the node once again, we should be able to see that the node has been labeled. So get nodes hyphen show labels. We can see that we should be able to see that this particular node should be should be labeled with disk type equals to SSD, right? Now if I just try to go ahead and try to schedule this particular pod on that node, we'll have to specify disk type, right, to be SSD. Okay, and if I just go ahead and try to create that pod will only be scheduled on the node that has the specific label that we have specified for node selector, right? So get nodes, and if we try to get the pods, and I'm using -o wide output wide to actually figure out with which particular node the pod is scheduled on. We can see that this particular pod is still in pending state. Let's just go and try to figure out why this pod is in pending state. And it says nodes didn't match node selector, right? And the reason is excuse me, we have a typo, right? It says disk type, but we have specified in camel case here. And if we just go ahead and try to apply the manifest once again, we should be able to see that this particular, okay, all right, so that particular field cannot be changed. So let's just go ahead and try to delete the pod, right? And if I create the pod once again, it should be scheduled on the node that we labeled, right? So kubectl get pods -o wide, and we can see that that particular pod is scheduled on this node, right, that we labeled. So again, if I relate it with taints and tolerations, this particular node can run another type of pods as well, another type of workloads as well. So for example, there is nothing that's stopping another workloads to be scheduled on this particular node, right? But if we want only some specific set of pods should be scheduled on this particular node, we can taint this particular node, and then we can specify the toleration here for the pod as well, right? So this is how we can use node selectors to actually schedule your workload on a specific node, right? And the one problem that I can see here is while specifying labels, we can just specify the exact match, right? So for example, if we specify node selector, we are saying that disk type should be equals to SSD, right? And there is no way we can specify, let's say, disk type is either in SSD or in, let's say, hard disk drive, right? So there is not very these conditions are not very flexible. We will have to specify the exact match, right? And to resolve this, or to go beyond this, we use node affinity, right? And again, node affinity can be used used for the same purpose that we use node selector for, right? So for example, using node selector, we specify which particular node this pod should be scheduled on, right? Similarly, pod affinity is used to specify which are all the nodes where this particular pod can be scheduled on, right? And this is how the manifest looks like if we try to use node affinity, right? And we can see that when we try to specify node affinity, we can specify two types, right? Again, spec.affinity just specifies, or it just like node selector, it actually specifies what are all the nodes where this particular pod should be scheduled, right? And it is a hard requirement or a soft requirement is dependent on the type of node affinity, right? When I say hard requirement or soft requirement, what I mean is, if the condition that is provided in the node affinity, if that condition matches, only in that case the pod should be scheduled, is hard requirement. But if it's preferred, in that case this is soft requirement, right? So again, we can specify another reason between node selector and affinity is we can specify more rich conditions, right? So for example, we can specify if the label or key is in some value. So for example, we can specify if disk type is in, let's say, SSD, right, or HDD, right? But we were not able to do that in case of node selector, but we can do that in case of pod affinity, right? So this is a very, what should I say, very major difference between node selector and pod affinity, right? And if we talk about type of node affinity, that is, we as of now have two types: required during scheduling, ignored during execution, and preferred during scheduling, ignored during execution. So it simply means this particular part is common, right? So let's skip that, ignore that as of now. Let's talk about required during scheduling. So it simply means, when scheduler is trying to schedule a pod on a specific node, this particular condition must be met, right? This is a hard condition, right? So disk type must be in either SSD or HDD to get this particular pod scheduled on a specific node, right? And these are just labels in of the node, right? So required simply means this is a hard requirement. This requirement must be met. And if we talk about preferred during scheduling, it simply means that this particular requirement that we have specified here is preferred, right? It should be met, but if there are no other options, this particular pod would be scheduled on a node, even if the node doesn't actually match or meet this particular requirement that we have specified here, right? So I think this difference is clear now. And yeah, we are just specifying expressions here. And similarly, for prefer during scheduling, we specify the match expressions here, right? So this is the basic difference between these two. If we talk about ignored during execution, it simply means that once the pod has been scheduled on a specific node, right, and then if we change either let's say nodes labels or pods label, and this particular condition is no longer met, in that case this particular pod would not actually be evicted, right? So once this is scheduled, even if the labels are changed and this particular requirement doesn't actually meet, in that case the pod will not be evicted, right? So this is the basic difference between these two affinity types, right? The other thing that I would like to discuss about is the operator, right? So the difference that we discussed about node selector and affinity is, in the case of node selector, we just specified exact matches, but in the case of node affinity, we can specify some set of operators. And to figure out operators, you can either refer the official documentation, or you can use or you can use kubectl explain command, right? So kubectl explain pod.spec dot affinity dot NodeAffinity, and then required during scheduling node selector terms match expression, and then operator, right? And this is going to tell us what are all the values that are supported for operator, and we can see that the supported values are in, not in, exists, does not exist, greater than, and less than, right? And these are self-explanatory, I think. So in, just make sure that the label key that we have specified for this particular label key, the values are among these values that we have specified, right? So disk type is in either SST or STT, right? And these are the labels of the node, right? Similarly, if we talk about not in, it makes sure that disk type is not in these values, right? And exists simply means in case of exists we will not have to specify values, right? Because in case of exist, it makes sure that, or it implies that that particular label is just present on the node, right? We don't actually care about the value. In that particular case we can use exist, and the opposite of that would be does not exist, and greater than and less than are also self-explanatory, right? So this is how we can actually use node affinity, right? If we talk about the other type that we have here, preferred during scheduling and ignored during execution, in that particular case, this particular syntax is familiar, right? Match expressions. But if we talk about weight, the value of weight field can be from 1 to 100 or between 1 to 100. And let's say there are some, we have specified some values, right? For this particular field we can see that this is slice, this is an array, so we can specify some set of values or some set of conditions, right? And all those conditions are actually added, right? Or summed up, and then they are actually compared for every node, right? So for example, let's say there are n number of nodes on your cluster, and all these values are summed up. For example, for this particular condition we have specified the weight to be 1. Let's say there is another condition that we specified with weight, let's say 20, right? And there are some other predefined conditions, I would say. For example, let's say if resource requirement is met or not, that also has some weightage, right? So all these weightages are summed up, and then they are compared between the nodes, and the highest matching nodes, the node that has the highest matching weightage is the node where this particular pod would be scheduled on, right? So this is the significance of weight field here, right? So I think this is pretty much clear. Now let's just go ahead and try to create this particular pod, right? So if I just go ahead and create -f, let's change the name is already changed. Yeah, and if we get the pods once again, we can see that the other pod has also been scheduled on the same node, because that node is the only node that has this particular label, right? So yeah, I mean, this is about node selector and node affinity. The other thing that I would like to discuss about is, what if we can see that value of node selector terms is array, right? So in YAML, this particular syntax or format specifies the value can be array, right? So value of node selector terms can be array, and in that case, if there are, let's say, more than one node selector terms, right? So for example, let's say we have more than one node selector terms, right? So in that case, the entire condition would be true if any one of this particular node selector term is actually met or is actually satisfied, right? So again, let me repeat that. Value of node selector terms can be array, right? So we can specify multiple node selector terms, and if any of the node selector term is met or satisfied, in that case this particular pod would be scheduled on that node, for which node the conditions are met, right? But we can see that the value of match expression can also be array, right? So for example, let's say we have specified one condition, and then we can also specify another condition, right? So in that case, both of these conditions should be met, and only in that case this particular pod would be scheduled on that node, right? So yeah, I mean, these are two special things that I wanted to discuss about. So in the case of node selector terms, either one of the values should be met, and in the case of match expressions, both of the or all of the expressions should be matched, right? And only in that case the workload would be scheduled on the specified node, right? So yeah, this was pretty much it about this particular video. Again, if you like the videos that I have been making, you can consider subscribing to the channel, and if you have some things to discuss about, you can comment, you can follow me on Twitter, and we can discuss about the things there as well. And I'll see you in the next one. Thank you.